Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here we go with our last lesson of the year, lesson 9.2.4, which is finding the volume of non-rectangular prisms. So these are prisms. They're going to follow that formula that we talked about yesterday with that L-shaped dessert, where we need to find the area of the base and then multiply times the height. In this particular case, it may not be really easy to figure out what the area of this non-rectangular base is going to be, but generally there are some strategies that you can use, like what we did when we were constructing or trying to find the area of composite shapes, where we were combining like rectangles and circles or triangles and circles and such. Well, when you have a pentagon or you have a hexagon or any other one of those polygons, you can always dissect them into triangles and rectangles and or trapezoids. And so that's what we're going to do today, is we're going to take a look at a couple of prisms where the base, we have to figure out what the area of the base is, and it's not real obvious at first. So in this lesson, you will investigate different strategies for finding the volume of non-rectangular prisms. The problems require you to describe how you visualize each shape. As you work with your team, ask each other these questions to focus your discussion. How can the shape be broken into simpler shapes? And those simpler shapes, I would say, would either be circles, rectangles or squares, triangles, or maybe trapezoids. And then can we break the shape into equal layers or slices? All right, so let's start off with just a typical box. Laurel keeps her seashell collection in a small box that's shaped like a rectangular prism. The dimensions are 4 by 3 by 5. She wants to make a bigger box for her shell, and she has found a pattern that she likes, and this is the pattern right here. The pattern has two sides that are pentagons. That would be the front and the back, and the finished box will look like a miniature house. So this would be considered a pentagonal prism, but you'd have to tip it up on end for you to see that the pentagon would be like the base. But remember, the definition of a prism is it's a geometric solid where it's got two bases that are parallel to each other. And right now we're going to say they're congruent to each other, although that doesn't always have to be the case. But we have to consider this the base and find the area of that pentagon in order for us to find the volume of the entire prism. So starting up here, part A, and it says use this resource page, but I'm not really crazy about that. We're not going to be cutting it out anyway. So I'll just work through it with you. You can draw the pictures as we go. And I do recommend that you try and draw these pictures. Just use your, what we did in class for 2-point or 1-point perspective and see if you can get a decent shape of what this box would look like. So first of all, with this one, calculate the volume of Laurel's original small box. What method did you use? Well, I would expect that you would use the 6th grade method, where since it's a rectangular prism, all you have to do is multiply the 3 numbers together. But if you think about what we did with our previous lesson, where we could say, all right, this is the base right here, and the dimensions of this base would be 4 by 3, so this is 12 square inches. And if you take one layer of that, that would be 12 cubes, 12 cubic inches. So how many layers can you get out of this? Well, it's 5 inches tall, so you'll be able to get 5 total. What is this? 1, 2, 3, 4, 5 total layers. So 12 times 5 is going to give you 60, correct? So if you use our formula that says volume is equal to the area of the base times the height, and the area of the base is 12, the height is 5, just multiply 12 times 5. However, you may have chosen for this one to just say, yeah, we're just going to multiply length times width times height. That would work as well, and you'd still get your 12 cubic inches. All right, now Laurel was trying to figure out the volume of this new box that has the pentagon base. One of her friends said, why don't you just find the volume of one layer and then figure out how many layers there will be? The hard part about that is like, okay, where do you start with your layers? And so that's where I always say, when you're dealing with a prism, the prism is named for its base. So this technically is a pentagonal prism. So what you would want to do is you would want to tip it up like this, so that it's sitting on its base. Oh, did I just give you some important information? Oh, well, forget that I showed that too. So another friend said, what if you separated the pentagon into two parts so that you have a rectangular prism and a prism with a triangular base, which you could do something like that, but let's just stick with what we're going to do. So here's a picture. If you're looking, you would have seen this in the online book. These are the dimensions of her box that she wants. The pentagon has from the top of it all the way straight down is 9 inches, and this dimension here is 6 inches. So if you look at it drawn this way, it looks like two trapezoids. This is one of the sides of the trapezoid that's parallel to this side. This is 5 inches tall. This is 9 inches tall, which makes the height of this trapezoid 3 inches. And this would be exactly the same. This is 5, this is 9, and that is 3. So if we wanted to, we could break this up into two trapezoids. Or instead of drawing this line here, we could actually separate it like her friend was saying and say, ooh, figure out the volume of this triangular prism on the top and figure out the volume of this rectangular prism on the bottom. And I would suggest, well, just find the area of this triangle and the area of this rectangle, and then put them all together, and you'll have the area of that pentagon. So that's what we're going to do. Once we find the area of that base, then we're going to break this up into 8 layers, because that's technically the height, okay? So let's actually start with the triangle part. We know that the distance from here to here is 6 inches, and the height has to be 4 inches since this is 5 and the total is 9. So for our area of a triangle formula, that would be 1/2 times 4 times 6, which tells us that the area of this triangular part alone is going to be 12 square inches. Then you take the rectangle part down here, which is 5 by 6. So that means that it has an area of 30 square inches. Put those together, and that's 42 total square inches for the total area of this base. If I now wanted to think about this in terms of two trapezoids that are exactly the same area, because those are congruent to each other, then we would take the area of the trapezoid formula, 1/2 times the sum of base 1 and base 2. Remember, base 1 and base 2 are the two sides that are parallel to each other. Those are the two bases. And then the height is the distance between those two bases, which we know is the halfway point here, which is 3. But then we're going to be dealing with 2 of those. So I just said, all right, once we find the area of one of them, let's double it by multiplying it times 2. Now, the benefit of doing that is, since I can multiply these in any order that I want because of commutative property, I can actually cancel out the 2 and the 1/2, because when you take half of 2, you get 1, right? We don't need to multiply all this times 1. So we can essentially get rid of the 1/2 and the 2 as factors, and that leaves us with base 1, which is 5 inches, plus base 2, which is 9 inches. That's going to be 14 inches, and then the height between them is 3. And so that gives us 42 square inches. Now, remember, I had canceled out the 2 with the 1/2 in the formula, which is why I'm not doubling this and making it 84. Had I not doubled it yet and just taken half of 42, this would have been 21. And then I would have, so this one is 21, then I would double it and make that one 21 as well. So the combined total is 42 square inches. Okay, so I've done it both ways. Both of them give me the same base area of 42 square inches. So now that I know that my base area is 42 square inches, now let's start working with the formula. The height is 8 inches. Remember, this is 42 square inches, and then every layer is going to be 42 cubic inches. So the first layer is 42, the second one's going to be 84, and so on and so forth. Well, this turns into a multiplication problem where you're just going to multiply 42 times 8. That's what the formula tells us to do for finding volume of prisms. Once you've figured out what the base area is by using whatever formulas you need to use and whatever strategies you need to use, like what we did over here, then you simply take that base area and multiply it times the height, and 42 times 8 gives us a total volume of 336 cubic inches. So how does that compare to our original box? Well, that is between 4 and 5 times as big as that original box that she had, so she'll be able to fit in many, many more shells. All right, so let's see what you can do with this one, okay? So I would like for you to do your best to draw this down and write in the measurements. Go ahead and pause the video. The base area is the trapezoid. Remember, the odd shape in your prisms is always going to be your base area. All the other shapes are always rectangles, but the one that's not a rectangle, if it's not a rectangular prism that is going to be your base. And so here is an example of a trapezoidal prism. And you need to find the area of the trapezoid, and this is the formula for finding the area of the trapezoid. You've got your height, which is the distance between the two parallel sides, and your two parallel sides are your two bases. So go ahead and plug those numbers in and figure out what the area of your base is. Now, if you were to tip this up on end, this dimension here is the distance between your two bases. So this is be like your, that's your height. So once we find the area of this, then we're going to break it up into 10 equal layers. So you just multiply this area times the 10. Go ahead and work through that and come back to me when you're done to see if you get the same answer that I have. All right. Hoping you try to do this because this is going to be on the test that you're going to have on Friday. You're going to want to know how to do this. So if you're waiting for me to do it on my own and you haven't done it already, pause this video and do it. Don't wait and just copy down my answers. It's not doing you any good to just copy me down. Okay, welcome back. I'm sure you've now been motivated to do all the work on your own. And let's see what we got here. So I'm plugging in the 25 and the 38 for my two bases. We add those together. Oh, look what I did. Hold on for a second. I did the same trick that I did before. Instead of taking half of 63, then multiplying times 12, I decided to take half of 12 and multiply 63 times 6. So when you do that, you should have gotten the area of 378 square feet. So that's the area of this side right there. Now, if we took one layer of that, that would be 378 cubic feet. But we don't want just one layer, we want 10 layers. So we have to multiply this base area times the height, which is 10. Oh, hold on for a second. That should not be there. That should be like that. So it's, yeah, that's a linear measure. That's 10 feet. And so 378 square feet times 10 feet, well, that's pretty simple, right? You just add the 0 to the end, and you get a total volume of 3,780 cubic feet. All right, so we will pick up on this process when we get into 8th grade, chapter 10. I'm going to tell you right now, most of the time, if there's an odd shape like what we had on this problem right here, where there's a pentagon for your base, they will almost always just tell you what the base area is. So when we get into problems like this in 8th grade, they'll actually be a lot easier than what we just had to do. But once you get into high school and you get into the application of this kind of math, once you get older and maybe you've got construction work that you have to do or whatever job you have that might be math related, you got to know how to deconstruct this area into shapes that you recognize, whether it's a triangle and a rectangle or trapezoids, and figure out what the area of the base is on your own. But in 8th grade, when we do this, for the most part, we'll be focusing on rectangles, parallelograms, and triangles and circles as your bases. So it'll be relatively simple, relatively. All right, good luck with your homework, and we will do the homework check and maybe a check for understanding tomorrow, and then I'm going to give you, oh wait, I might be doing study guides. I can't remember what the schedule is, but at any rate, we're now at the end of our lessons, and we're marching toward the end of the year and the last chapter test, which will be on Friday. All right, good luck with everything. Bye.
Hey, feeling good.